Hello class, Professor Gavoor here. We have an exam, a quiz tomorrow, and here's the mock quiz I gave you. I'm using the Excel version, so it makes it easier for me to show you how you solve these problems. So here's a binomial distribution. There's 20 trials. I don't know why. Well, I didn't go to 20 because it pretty much at 15 it's 0 and 1. And it's a 5% defect rate. So what is the probability of finding 3 defects in a sample? Well, that's always a probability density function. This says exactly 0, exactly 1, exactly 2, exactly 3. So that number, 0.0596 or 5.96%, is the answer to exactly 3 defects. So I say equal, and I go click on that. Boom, good for me. What's the problem? How do I find more than 2 defects in the sample? Well, the cumulative distribution is 0 or less defects, which is just 0. So that's why the probability density function and the cumulative density function are the same, 35.85%. But then it says 1 or less, so I add these two, 1 and I add 0. So I get 73.58. Here's the probability of getting 2 defects or less, 92.5, but I want 2 or more. So I want all this. I basically want to add all these numbers. But if this number here, 92.45% or 0.9245, is 2 or less defects, and that's 92.45, I want to say this is equal to the complement of that, 1 minus 0.9245, and I get 7.55%. Again, I'm leaving it in decimals to 4 places. What's the problem of getting 1 or 2 defects in the sample? Well, there's a probability of getting exactly 1. There's a probability of getting exactly 2. So if I add those together, that's a probability of getting 1 or 2. So let me say that's equal to exactly 1 plus exactly 2, or 0.5660, 56.6%. What's the probability of getting less than 3 defects in the sample? Does that include 3? No, less than 3 means 2 or less. Well, it was a kind of a trick question. So it's equal to what? This one, the cumulative distribution. That's the probability of getting 2, 1, or 0. Boom. There's the answers to those. What's the mean? Is equal to n times p. What's n times p? There's n times p. Oh, I get 1. Ooh, that's not good. Let me try to make that into decimals. To 4 decimal places, it's 1. N times p. Oh, I'm sorry. It's not a. It comes out to exactly. I expect to find exactly. The mean is 1 defect. Sorry. At 5% defect on 20, it's NP. What's the standard deviation? Well, it's the square root of the mean, which is 1, n times p, times q. What's q? I forgot what q is. Oh, yes, it's 1 minus p, or 0.95. So my standard deviation is 0.9746. Let's take it to 3 decimal places. Okay, very good. Let's go to our geometric distribution. It's the same thing, but it's a different distribution. You can see by the picture. I didn't put the picture on the exams, and I'm not asking you on the exam for the standard deviation. The formula is just too complicated, and we're doing it by hand. So let's start with the mean first. This is very simple. The mean of the geometric distribution. Remember, this is the one where it's a Bernoulli trial at each one. Here's 0.4 is the probability. and of success, whatever the success was. I gave some blah blah in the mock exam, but that doesn't matter right now. I give it a try. What's the probability? And it shouldn't be. Yeah, boy, I hope I didn't put this way. There should be. There is no 0 here. It starts at 1. And what's the probability? You try things 1, 2, 3, 4 times, see if you have success. So what do I have here? I have to look at my formula. So I have to bring this down to see, make sure I did this right. So C2 times 1 minus C2 to the B to the 6 minus 1. Boy, I hope I didn't do that wrong on the exam, on the mock quiz, but if I did, this will help you. That's better. The first probability has to be this, and let's bring this all the way down. Okay, there we go. That's better. Sorry about that. And then this works out. Okay, so my probability here is going to be, the mean is going to be 1 over p. So I do equal to equal to 1 divided by p. So it's going to be 2.5 is where I expect the mean of my first success to be. Each trial is 40% possible. So what if I do it in exactly 5 tosses? Exactly, when it means I'm always talking about the probability density function, this side, where it's an exact. Exactly 5 tosses is right here. It's 5.18%, or 0.0518. So I say equals to exactly 5. Yay, good for me. In 4 or less, well, that's definitely the cumulative density function. This is 0, 1 or less, and there's only one try, so it's actually 1. 2 or less, which means 2 or 1. 3 or less, which means 3, 2, or 1. And 4 or less is right here. And I think this was a toss of a loaded dice or something like that, whatever we're looking at. So it's 0.874. More than 3 tosses, well, there's 3 or less. So more than 3 tosses is all these added up together. But since this is 3 or less, more than 3 is just the complement of 3 or less, which is 0.784. So I do equals 1 minus 0.784. If I'm going too fast, you can stop it and look at it again. Back it up a little bit. Between 3 and 5. Well, there's exactly 3, there's exactly 4, there's exactly 5. Why don't I add those 3 numbers together, and that would give me 3, 4, or 5, between 3 and 5. I can also do 5 minus 2 and probably get the same thing in a cumulative, but let's make it simple. Let's just use this. So I'm going to say this is equal to the sum of, and then what am I taking the sum of? This, and this. And I do parentheses, and I say, okay. And that's 0.2822 or 28.22%. So that's how you do the exam. I'm sorry I did this. I had this set up badly. And let's see if I... Oh, wrong thing. Let's bring this up. And here's the mock quiz. And if I look at it, what did I do? There's problem 1. There's problem 2. I did it wrong. Try to answer those questions. Even though I did it wrong, do those answers with these problems. It's the same way I did it. Or I'll update this and put it in the announcement. with the right numbers in there. All right, thank you so much. And I will be in class early tomorrow for people that want help, which you may need it after my horrible explanation here. We'll see you tomorrow.